Hello everyone. So welcome to the third lecture on kinematics. और इस लेक्चर में let's review what we did in the last lecture. In the last lecture हमने पढ़ा था velocity and there were two kinds of velocities. The first kind was the average velocity depicted by some strange looking triangular brackets, and then there was an instantaneous velocity. Simply depicted by v with a vector head. Now what was the main difference between these two velocities? Just let's review it for a moment. Average velocity was कि आप एक certain distance या certain displacement आप अगर cover करते हो, let's say in 1D if you cover a certain path, let's say if you move like this, so this is your final position and this is your initial position, and this here would be called as your displacement. इसे हम लोग कहेंगे displacement. So displacement is nothing but final position minus initial position. Now if we look at that in 2D, x-axis and y-axis, and if your particle covers a path something like this, maybe, then this is your initial position and this is your final position and this is your displacement. This red line represents the displacement, and the displacement in any time and always, the displacement is equals to final position minus initial position. It can be in 1D, it can be in 2D, or it can be in 3D. That is 1D, 2D or 3D, it does not matter. In any set of dimensions, your displacement will be final position minus initial position. So now coming back to what was average velocity. Average velocity was displacement by time, and this was your average velocity. So we just looked at the final value, we just looked at the initial value, we found out what is the difference between the final value and initial value, and we also looked at the time that it took to reach from initial value to final value. So let's say the particle has started from point A, then goes to point B, then goes to point C, and then returns back to point D. So the time taken from moving from to move from A to B to C to D is T, and this time is something that we are considering over here. This is the time taken to complete the entire path of the motion, right? And that is your average velocity, that is displacement by time. Now what was your instantaneous velocity? Your instantaneous velocity was a very small displacement divided by a very small time. So instead of looking at the entire path and the entire displacement, we were just looking at a very small displacement that happened in a very small time. So this small displacement ds that happened in a small time dt, and that is how you find your instantaneous velocity. Okay, and this is how you find your instantaneous velocity. You take a small displacement and you divide it by the small amount of time. The general way to do it in one dimension, let me change this. The general way to do it in one dimension is x equals to x. Let's say the position is x equals to, let's say 3t squared something. Okay, so if you want to find out the instantaneous velocity, we'll use the formula dx by dt, and And in order to differentiate this, in order to find the small displacement with respect to small time, all we have to do is apply this formula. So if it is t to the power of n, the differentiation with respect to time is n into t to the power of n minus 1. So 3 times of 2 into t to the power of 2 minus 1, or 6 into t to the power of 1. Now let's say we want to find instantaneous velocity at t equals to 4 seconds. So the instantaneous velocity is equals to 6t t to the power of 1, and we will substitute 4 seconds in this time. So we are going to get 6 into 4, and that is equals to 24 meter per second. And that is a way to find the instantaneous velocity. Uh, we can have some other situations like position is equals to, let's say, t square minus 4t. Now this could also be a position. अब इस तरह के क्वेश्चंस हमने लास्ट उसमें डिस्कस नहीं किए थे, तो आई वांट यू टू लुक एट दिस केयरफुली कि यहाँ पे हो क्या रहा है. सो द इंस्टेंटेनियस वेलोसिटी इज गोइंग टू बी dx by dt, and we are going to distribute the differentiation. We are going to distribute the differentiation. What do we mean by distribute the differentiation? Let's say for example, if you have studied in your classes 6th to 9th, let's say you are multiplying a with b plus c. So what do you do is you multiply a with b and then add with the multiplication of a and c. So this is what we call as distribution. Now we can also distribute not just multiplication, we can also distribute differentiation. So it will be d by dt of t square minus 4 d by dt of t. And we will apply the formula over here. The differentiation of t square is going to be 2t. I want you to look at this formula here, how this works out. So t squared will give you 2 into t, and t ka differentiation will give you 1 into t ka power 0, or simply equals to 1. So minus 4. And that is your instantaneous velocity function. This is what we call as your instantaneous velocity function at various instants of time. So let's say that you want to find instantaneous velocity at t equals to 1 second and t equals to 2 seconds. So the instantaneous velocity is going to be 2 into 1 minus 4, that will be equals to minus 2, and minus 2 would mean what? Minus 2 would mean that particle is moving backwards. The particle is moving backwards. A negative sign would imply that the particle is moving backwards. Now if you want to find instantaneous velocity, this is t equals to 1 second. Now if you want to find the instantaneous velocity at t equals to 2 seconds, so you are going to do 2 into 2 minus 4, and that is equals to 0. So the particle is at rest. Particle is at rest. Yes. And if you want to find out the instantaneous velocity at, let's say, t equals to 3 seconds. So 2 times 3 minus 4. What are we doing here? Whatever is the value of time, we are substituting in this formula. Whatever is the value of time, we are substituting in this formula. So t equals to 1 second, 2 seconds, or 3 seconds, we are going to substitute the value of time in this formula over here. So that is 6 minus 2, and that is equals to 2 meter per second. So this is positive. You can see this is positive. So particle is moving forwards. Particle is moving forwards. And this is how you find out the instantaneous velocity. Now here in this case, I want to discuss why is instantaneous velocity, although we have done it in the last lecture as an introduction, and I want you to go and see it, but I want you to discuss, I want to discuss this again. Why is instantaneous velocity a better representation of motion as compared to average velocity? So this is something जो हम discuss करना चाहते हैं कि instantaneous velocity किस तरह से एक better representation of motion है as compared to average velocity. So we'll take up a motion here. Let's say the position of a particle is given as t square minus 4t, the last one, t square minus 4t. Now I want to find out the average velocity. I want to find out the average velocity between 0 to 6 seconds. Let's assume we are going to find out the average velocity between 0 to 6 seconds. The way to do it is simply we'll find position at 6 minus position at 0 divided by 6, that is the total time taken. So 36 minus 24 is going to be equals to how much? So we are doing simple 36 minus 6, 36 minus 24, and that is going to be 12. And the position at x equals to 0 is going to be equals to 0, so divided by 6, and that is equals to 2 meter per second. Now what does this data, what does this little piece of data tells us? What is this data telling us? This data is telling us that the particle has moved forward. Why is it telling us that the particle has moved forwards? This is because the answer is coming out to be positive. As you can see, the answer is coming out to be positive, and this data tells us that between 0 and 6 seconds, the particle has actually moved forwards. Okay, but let's try to understand कि हमें instantaneous velocity क्या बताती है. So this is the position again, t square minus 4t. I don't know why am I writing this again, but chalo koi baat nahi. Instantaneous velocity is dx by dt, and since we have already differentiated it, so I'm not working on this again, so it is going to be 2t minus 4. Now I want you to look at the instantaneous velocity at various instants of time. For example, at t equals to 0 seconds, the instantaneous velocity is minus 4. T equals to 1 second, the instantaneous velocity is minus 2. 2 seconds, the instantaneous velocity is 0. Let me move this up, right? Or why move this up? Let it be here. So I can write it over the side, over the right side. Okay, so t equals to 3 seconds, instantaneous velocity is 2 meter per second. T equals to 4 seconds, the instantaneous velocity is 4 meter per second. T equals to 6 seconds, let's say the instantaneous velocity is 12 minus 4, that is 8 meter per second. Now what does all this data tells us? This data tells us some very interesting hypotheses or very interesting observation, not hypotheses, an observation that let me draw a straight line here. The particle starts at x equals to 0, but at t equals to 0, my particle isn't moving forwards, it is moving backwards, as you can see with regards to the instantaneous velocity. So instantaneous velocity is minus 4, hai na? So if it is minus 4, my particle is actually moving backwards with a speed of 4 meter per second backwards with a speed. But as the particle moves backwards, the speed is decreasing. So let's say here it is -4, but the speed here has decreased, that is -2, and at 2 seconds the speed becomes equals to 0. The speed becomes equals to 0, right? After this, the particle starts to move forwards. As you can see from the data here, if you will put any time above and ahead of 0, above and ahead of 2 seconds, not 0, 2 seconds. Let me write this properly. If you put any time ahead of 2 seconds, so you can put 2.5 or 2.75 or 3 seconds, you will get a positive velocity. You can check this from the question here, from the result here, that if you put the time 2 seconds, more than 2 seconds, 2.5, so 2.5 times 2 is 5, 5 minus 4 is 1. So if you put the time ahead of 2 seconds, the particle has got a positive velocity. So for t greater than 2 seconds, I need space to write it someplace. Okay, I can write it here. For t less than 2 seconds, particle is moving backwards or left. For t greater than 2 seconds, the particle is moving forwards. Space is less, but I guess you understand the point. The particle is moving forwards or right. So this instantaneous velocity, so at t equals to 2 seconds, it is moving up till t equals to 2 seconds, it is moving backwards, and then after 2 seconds, it is moving forwards. And as you can see, जैसा आप देख सकते हो यहाँ पे कि instantaneous velocity gives you a more accurate description of the motion. Instantaneous velocity gives you a more accurate instantaneous velocity. Let me write this down. Instantaneous velocity gives us a more accurate description of motion. Let me go back to it once more and explain this to you in very fewer words this time. So if you look at this, if you look at the average velocity, it just says it is +2 meter per second. That means the particle is moving forwards. But if you look at the instantaneous velocity, it tells you that at the beginning of the motion, its velocity is -4, so it is moving backwards. Its velocity is slowly reducing. At t equals to 2 seconds, the velocity becomes equals to 0. The particle stops momentarily, and then the particle moves forwards. And as you can see, all the velocities are positive after t equals to 2 seconds. So instantaneous velocity actually gives us a more accurate description of motion as compared to the average velocity, and that is the point that we wanted to discuss in this video. Okay.